now that we have our vocabulary and our perspective for general sinusoidal equations and graphs, let's look at a few problems that will allow us to relate written descriptions, equations, and graphical images and tie them all together to solve our puzzles. Let's look at our first puzzle. Here we're going to go from a description of a sinusoid to its graph and the equation. Here's the setup. Suppose that a sinusoid has a period of 15 degrees per cycle, an amplitude of 8 units, a phase displacement of -6 degrees with respect to the parent cosine function, and a sinusoidal axis 3 units below the theta axis. Without using your grapher, sketch this sinusoid and then find an equation for it. For any of these puzzles, there are 5 pieces of information we need. The 4 variables in the equation, a, b, c, and d, and the choice between a sine or a cosine. So let's start with the choice. In this question, our choice has already been made for us. We are going to use the parent cosine function. So we know at least that much of our equation and our general starting point for our graph. To find the other 4 variables, we have to remember what each one of them represents and where to start. For me, I like to start with the sinusoidal axis because everything happens around the middle. So our sinusoidal axis is 3 units below the theta axis. So I'm going to draw a dashed line 3 units below the theta axis here. That dashed line represents the c value in our equation, our vertical translation. The next thing I will work with is the vertical dilation. How far did we stretch our graph above and below our sinusoidal axis? Here, that's known as the amplitude, and we can see that it's 8 units above and below our sinusoidal axis. So if we start at -3 and move up 5, or move up 8, we will end up at 5. So I'm going to draw another dashed line at my upper bound. I will also subtract 8 from -3 and end up at -11 and draw a dashed line at my lower bound. So now I've dealt with the vertical transformations. I've found my vertical translation to my new sinusoidal axis and my vertical dilation to a new upper and lower bound. The next thing we'll work with are the horizontal effects. Again, I'm going to work with the translation first. So we have a phase displacement of -6 degrees with respect to the parent cosine function. Okay, to understand that, we need to recognize that our parent cosine function starts at a high point when x equals 0, or when our angle is 0 degrees. So that would mean that originally I would have a high point here on the y-axis, but we have shifted -6 degrees with respect to that original location. So now my high point has moved to -6. That gives us a starting point to sketch the rest of the graph. The next effect we deal with is the horizontal dilation, or the change to a new period. Our new period is 15 degrees per cycle. So that means that from this first high point at -6, 15 degrees later we'll be at another high point. So -6 plus 15 gives me 9. This pattern is going to repeat. So starting at 9, if I add another 15 degrees, that will take me to 24, and I'll have another high point. From there, I can figure out my low points. which should be halfway between my high points. So halfway between -6 and 9 would be half of 15 degrees. So half of 15, 7.5. 7.5 plus -6 would put me at 1.5 degrees, which would put me right about here. And then another 7.5 added to the 9 degrees would put me at 16.5 degrees for another low point. Or I could have taken my original low point of 1.5 and added the 15 degrees, because that's how long it will take to repeat a low point. I've now got points above and below the sinusoidal axis where I can mimic a sinusoid. I have created a new sinusoid. I've sketched my sinusoid now. To come up with the equation, we have to remember how each of these effects or dilations or translations, work into our general sinusoidal equation here. Our A value is known as the amplitude, and that's the distance away from our sinusoidal axis, the midline. So as we saw, the distance above and below the midline was 8. So our A value is going to be 8. Our B value is the dilation factor, or the reciprocal of the dilation factor, for our period. And we came up with that relationship where B equals 360 over our observed period. So in this case, our observed period was 15 degrees. So our B value is going to be 360 over 15, which turns out to be 24. Our C value, hanging out there at the end of the equation, is the location of our sinusoidal axis, or our midline. So, as we can see, our sinusoidal axis occurs at -3. So our C value is -3. The D in our equation is our horizontal translation. And we see that our horizontal translation, our high point shifted 6 degrees to the left of the y-axis, which means that our D value is -6. And our equation becomes y equals 8 cosine 24 theta plus 6, because we're subtracting a -6, minus 3.